All right, and with that said, I would like to bring Arun and Gokul online here. If you'll give me a brief moment. Arun, I'm turning on presenter mode for you, and Gokul, I'm turning it on for you as well. So with that, we have Arun and Gokul here, who will be giving the presentation. I will go ahead and step back and hand the show over to you, gentlemen. Go ahead.
All right, thanks, Charles. Hello, everyone. I'm Arun Kumar. I'm part of the product management team here at Palo Alto Networks and manage the DNS security product. And I have here with me Gokul.
Hi, everyone. This is Gokul Pokuri. I'm a technical marketing engineer here at Palo Alto Networks. I'll be doing a quick demo later. Thank you.
So let me share my screen here. All right. Hope you guys can see my screen.
Yep, you're good.
All right. Awesome. So let's kick it off with respect to what we have in terms of advanced DNS security, how the existing solutions work today. And as you can see on my screen, there's a brand new service that we just rolled out a week back. And we'll touch upon it and show you how it works. So before we get on to the whole solution aspect of it, I just want to point out a few things from a DNS standpoint. Yeah, as you all probably are already aware, DNS protocol is essential for every organization. It is needed for translating those domain names to IP addresses. Now, this is an internet-facing protocol, which means it has to be allowed from your perimeter, and it has to be able to resolve things that are out there. So things can basically, DNS can be used to send data out and can be also used to bring in data into your network. And we see a lot of ways DNS in general is basically used by attackers. Now, this is just a small snippet of the type of threats that we see over DNS. Now, a few things just to point out here are like things like data exploit. As I mentioned, DNS has to be allowed to the internet, which means attackers can use this protocol to take data out of your network, or in some cases, bring in some kind of an executable or something back into your network to do any kind of lateral movements. And there are other threat vectors too. Like last year, we released Advanced DNS, and the focus of that Advanced DNS solution was to identify things like DNS hijacking. Now, DNS hijacking itself is not new. It's been around for a while, and there have been kind of like solutions built in, things like DNSSEC that got implemented. But because of poor adoption of DNSSEC in general, there are still several domains out there that do not utilize DNSSEC, which means an attacker can basically somehow compromise either the DNS servers or the DNS authoritative servers some of these domains have, and be able to respond back with IPs, etc., that they have. So DNS hijacking is a technique where you think you're going to a benign domain, but the attacker somehow has compromised the backend authoritative DNS server, or maybe just because of how DNS protocol in general is clear text, has managed to inject some data into the DNS response and has been able to redirect your HTTP request or something to a malicious server that they control. And we see a lot of these things happening in the news. Just recently, we saw something called Hazy Hawk, which is basically looking at all kind of redirections happening for your if you have several domains that you own, and if you're using things like Amazon S3 bucket or some cloud provider to host the content, attackers have managed to basically figure out if there are any kind of misconfigurations within your DNS configuration and be able to hijack those queries and be able to redirect them to malicious content that they own. Then there are things like dictionary DGA, malicious TDS. Those are like dictionary DGA is a technique where an attacker has basically compromised a device in your network and is now using something called dynamic, like a domain generation algorithm, to connect to a command and control server. Now, these domain generation algorithms, it can generate domain names on the fly. So if it sees basically some security vendor is blocking a domain, these algorithms can quickly switch over to a different domain. And if the attacker has registered one of those domains, they can basically connect to the command and control server, and the attacker can then manipulate things. So those are just a few components. So one of the things, as I mentioned, DNS hijacking, we released it. We had detection come in last year. The whole goal of the detection was to able to look into the DNS response payload and figure out if there is any change in the IP addresses that are coming back in the response. So as I like to just again summarize the whole DNS hijacking technique, it's like as an user, you're thinking you're going to a benign domain, but somewhere along the network or in the authoritative server itself, the attacker has compromised that path and is be able to redirect your domain name queries to a different IP address altogether that they control. And these are just a quick snapshot of the different types of techniques out there that are basically part of the whole DNS hijacking framework in general. And we have seen reports out there which shows that there is still a huge prevalence of DNS hijacking, and that made us focus on having this ability to inspect DNS responses real time, look into see what kind of resolutions are happening out there, and if we see any kind of malicious IP or your domains being redirected to some kind of a malicious content, be able to intercept those at the DNS level and basically protect your network. So and with the leverage of AI now, it's become far more easier, right? So for the attackers are also having different AI tools to come up with innovative solutions for them. So they have things like ransomware as a service offerings, or basically phishing as a service offerings, or they have the chat GPT equivalent called worm GPT, where they can put in something and basically get a malicious script or whatever they need from those AI models. Now, it's become far easier for an attacker to come in and do something. They don't really need to be proficient with coding, etc. You can leverage some of these tools and be able to immediately get into this attacking techniques. So to fight all these kind of techniques, you also need to adjust few things on your end. As a security vendor, we have to also leverage AI as much as possible. So we have all these detection models that are out there. We feed them with all the DNS data that we see, whatever that we see on the internet, and figure out how benign traffic looks like, and basically come up with a model where if anything is not fitting that paradigm, if there is any kind of anomaly there, have these models detect them and be able to dig deeper and figure out if there are any kind of malicious attacks happening. So that is the basis of basically our solution today. So what we have is, before we launch this Resolver solution, our DNS security essentially worked through our firewalls, through our SASE solutions. So we were not necessarily a resolver. What would happen is you have these firewalls sitting at the perimeter, looking at any DNS traffic going through it. If we see DNS traffic, we make a copy of it, and we basically send it to our cloud for analysis. This cloud is being fed with various set of DNS data, so like threat intel coming in from our other security services like Wildfire, URL filtering, threat prevention. Then we have all the passive DNS information coming in from various sources, including our own firewalls. So we feed all these data into our models. If we see that any of these DNS requests are going to a malicious domain, we are able to intercept that packet and be able to redirect those queries to a sinkhole mechanism or something. So today the goal here is hardware firewalls, software firewalls, or SASE solution. If they see DNS traffic, they make a copy of it. We send that copy to the cloud. We analyze both the request and the responses. And if we see any anomalies, we push a verdict back to the firewall. And the firewall is then able to intercept that DNS query and redirect that host to a safe content. So that said, we also saw a few challenges in general with respect to a few of our customer bases. Now, we launched this ADNS Resolver service just last week. And the whole goal is to be able to have our customers point to an Anycast IP in the cloud and get access to our Advanced DNS Security Cloud Engine. Now, a lot of our customers we have seen out there not necessarily have our firewall solution or SASE solution, or they may have a mix of different security vendors enforcing things for them. So for such customers, it makes it easier if you have like a resolver-based deployment option for DNS security. So what we built was this cloud infrastructure, again, where we host 2 Anycast IPs. And what the customers need to do is essentially from their DNS server, if every enterprise will have their local DNS server, that local DNS server essentially just need to forward the DNS traffic for any external resolutions to these 2 Anycast IPs. And as soon as we get that Anycast IPs, now what we will do is we will analyze again, since this resolver service is co-located with our Advanced DNS Security Cloud, we can inspect the requests and responses, be able to intercept any kind of malicious packets, and safeguard for you from any kind of threats out there. So the goal here is be it any location, all you need to do is just point to these IPs and immediately get access to our Advanced DNS Security. Now, since it's a cloud-based service, what it also includes is we will basically include a Strata Cloud Manager for managing the configuration, and also provide you Strata Logging service for logging all the benign and malicious DNS traffic that we see. So these will be included. We'll touch a bit about the licensing aspect of it towards the end. But the solution in general is fairly simple to deploy. All you need to do is just point to those 2 IPs that you see on these slides here, and you get access to our DNS security solution. And this is just a quick coverage of what we have. And some of these starred items that you see out there are basically something that our research team, who constantly works with Unit 42 and other threat researchers out there, if we see any kind of threats, we immediately end up building a detection model for it, adding those protections to our cloud, so you immediately get access to those protections. And one thing that I'm fairly proud of the team is a lot of these detection names that you see out there are coined by us. So things like strategically aged domains, domain masquerading, all these things were something that we identified. We continuously observe the DNS traffics out there. If we find a specific threat pattern, we immediately add coverage for it, give it a name, and add those protection to our customers. So how ADNS Resolver works, Gokul will show you a quick demo of how easy it is to set up. But just a quick summary of how things will work is you have all your devices essentially pointing to some local DNS server. This local DNS server will need to be configured to forward DNS traffic to the Anycast IPs that I showed previously. Once the traffic comes to our cloud, we will basically work with the root servers out there, try to resolve the domains, and in the process, also analyze those DNS requests on the fly, figure out if there is any kind of malicious requests happening. If we see anything malicious, we have a mechanism called sinkhole. And to just give you a brief summary of what sinkhole is when we see the traffic in the internet, we do not see the actual source IPs of or source users of the infected clients. So sinkhole is a mechanism for us to basically be able to identify who that source user is who was trying to connect to a malicious content. So if we see a malicious content, we basically redirect those DNS queries to a sinkhole server that we own. There is an IP address associated to it. And what will happen is the DNS response for that domain, we will send that IP address as the A record or something. So when these devices get that A record, they will try to connect to the sinkhole page. And if you have a firewall sitting in the path here or any device sitting in the path, you can monitor our sinkhole IPs and be able to identify who that source user was, source IP was, and be able to like take that information and feed it into your SOC and basically go through the next cleanup process. So the goal here is you have the DNS flow here. Once we return back a malicious IP, sinkhole IP, basically the devices will connect over HTTPS to the sinkhole page. If whatever device is in the path, it'll basically be able to log that traffic, and so you have that visibility. So that said, I want to pass it over to Gokul for a quick demo, how to Shield basically walk you through on how easy it is to set up this whole solution. And he will also walk you through some of the visibility aspect of it. So Gokul?
Sure. Thank you. Thank you, Arun. Let me share my screen.
While you're doing that, we did have a couple of quick questions come in. So is this ADNS Resolver only available to Palo customers? And what traffic does the local DNS server forward?
So yes, so the Resolver in general is not a public resolver. So we are just making it available to our customers. So we have few checks in place to make sure we understand which customer the traffic is coming from, and Gokul will walk you through it. But the second question with regards to what your DNS server needs to forward, every local DNS server will have basically some kind of a mechanism where there is a concept called DNS forwarding. So if the local DNS server will have the knowledge of all your internal domains, so if you are using things like Confluence or Jira or something, the local DNS server will be able to resolve those things. But anything that it cannot resolve, it can be set up to forward those things out to an external resolver. So any public-facing domains out there, you can have your local DNS be configured to use our resolvers as the next hop. So with those mechanisms, any external resolution will come to us, and we'll be able to resolve that for you.
And then will you be talking later on about the licensing for this product?
Yes, I'll briefly touch upon it.
Okay, so we'll get back to that in a few minutes then for you, Andrew. So, okay, thank you.
Sure. Okay. Hi, everyone. Now I'm going to demo our Advanced DNS Resolver. Here is our demo setup where we have a client machine in a branch setup, and its IP is 52.8.142.57, and it's configured to forward all the DNS traffic to anycast IPs, that is ADNS Resolver anycast IPs 96.9, 97.9, 96.9, 96.9. So like Arun mentioned, what happens once we forward the DNS traffic, what's the expected behavior is, if we have the rules configured for this branch network, the security rules, accordingly, we will do content categorization, DNS security, and also resolution. And our advanced DNS resolver is powered with threat intel derived from varied sources like WHOIS, user DNS traffic, passive DNS, threat intel from other core subs like advanced URL, advanced wildfire, advanced threat prevention. It has the same capabilities of advanced DNS security, whether it's deployed on firewall or on SASE. The security capabilities are same, but we have additional capabilities like content categorization, sinkhole, block pages, etc., which we'll look into. So now, without any further delay, let's go into the UI screen of Advanced DNS Resolver. So this is the Strata Cloud Manager, and on the configuration tab, there is Advanced DNS Resolver configuration MFE. So once I'm in Advanced DNS Resolver, I would see this as a home page. Here we have few options, right? Connection source, verification status, resolver info, sinkhole. But let's go into the configuration. There are few steps to create a configuration, like connecting to a branch network, like configuring the branch network. So the first step is to create connection source and add the connection source. This could be your branch network or branch, any end client IP. For example, in this demo, I'm using end client IP. So I already have two connection sources here, like branch Texas and branch Santa Clara. These are the egress IPs of that network. We have an option to enter /32 IP address, or a range of subnet starts from /28. So for example, let me add like branch NA. And what is the next step is to configure a security profile. The DNS security profile is where we have content categorization DNS security. We can either select best practice or security profiles that are already there. Let me just go over two security profile configurations here. These are the security profile configurations. We have best practice already defined, which has all DNS security categories, advanced DNS security categories set to sinkhole. Like sinkhole means what we do is we force DNS response. If at all, if we see DNS requests coming from matching this any of this category, we'll send a DNS response of our sinkhole IP, which then user sees that as a block page for it. And content categories also, we support about 61 categories, and each one has an action like allow, block, sinkhole, alert. For the best practice, we have alert configuration as content category action, and DNS security, advanced DNS security has sinkhole. So either you can create a new security profile or you can just select a best practice. So that's the configuration as part of the security profile. In addition to the categories, we also have overrides like allowed FQDNs, EDLs. So allowed FQDNs are like you can enter any domains, some of the domains which you want to allow list here. And EDLs are the definitions where you can look into importing third-party or any threat intelligence feeds that are on the server, where you can configure those server definitions directly from here. EDLs. We have the EDL definitions also configured under DNS security profiles external dynamic list. Here, you configure that EDL definition and attach it to the security profile. Let me go into the connection source now that we have some background, right? So let's click on branch NA. Maybe I'll create a new security profile here. Security profile, file new, and then I have this automatic categories already imported. Basically, the action sets to alert and sinkhole from the best practice. I can change accordingly. For example, this I want sinkhole. I want the sinkhole. Maybe this allow and maybe dating to sinkhole, etc. So this is how we can configure and save overrides if I have anything, for example, abc.com, etc. Like I can save this configuration and it will be added to security profile new here. And if I reload in the security profiles, it will be also added to security profiles in the screen. And the next step is to go and add an IP. So as I said, we have a range that supports from /28 to /32. For example, I'll be selecting a dummy IP here. /32. So what happens is once you add, you would need to save the configuration, right? After saving, you will have an option to verify IP address. So this is where our verification mechanism kicks in. Once as an admin, you enter a egress IP address of your network, you also need to verify that IP in a way so that the traffic originating from that public IP, we will be able to validate it. So the verification mechanism is you would need to send this verify IP, this URL link to any of the device which is in the same network as in the egress IP you configured, and click on this verify IP and get the token and enter this token to verify it. So that's the verification mechanism. As I already have the configuration here, this is a dummy IP, so I'm not going to do verification. For example, for branch Santa Clara or branch Santa Clara, we already have that verified. This is specifically for connection source and security profile, which covers majority of your configuration is just like a couple of steps, right? And you'll also see connection verification status of all your connection sources here, whether it's verified, unverified, or partially verified. Let's say if I have multiple IPs in a single connection source, I can add more IPs, right? I can add more IPs. If some are verified and some are unverified, it will be marked as actually verified kind. These are our Anycast IPs 96.9, 97.9, 96.9, 96.9. It's same for all the customers. As we have a verification mechanism, we'll only allow DNS traffic that have connection source and have the IP address verified, IP address or subnet verified. Only from those sources will accept it. The DNS resolver accepts the request. If not, they'll get an X domain as a response. Here are the DNS sinkhole settings. By default, we have Palo Alto Networks sinkhole, and we also have an option to customize customization if you want to put your own server FQDN. For example, Palo Alto Networks sinkhole, you have option to customize your logo and also add your message. Here I added Palo Alto Networks logo and our custom message to talk to IT Infra portal, etc. if there are any issues. On the custom page, block page, we'll see domain category, and username for some if it's coming from agent. But if it's campus branch use case, right now that's what we support. We would not see username from the block page. There is also a prerequisite. We need to install Palo Alto Networks root certificate on the end client machines and also on firewalls, so that the Palo Alto Networks default block pages can be shown on the end client machines. So now we have seen the configuration part, right? This is the configuration part. There are other fields like where we can see analytics, but before going to that, let's go into the second step, right? Second step is to go access branch network. For example, branch Santa Clara. I'll go into branch Santa Clara, this IP machine, and show and point this machine to primary IP, secondary IP of Anycast IPs. So this is my RDP machine. This is also the same machine as branch Santa Clara, as you see, 52.8.142.57 is my public egress IP address. And since this is an end client machine, I'm just adding the DNS server IPs on the end client machine here, 96.9, 96.9.
My apologies for interrupting. We're just seeing a browser window at the moment here.